Monday the 5th of May, and the new topics today are volume of prisms, volume of cone and spheres, and density. So volume. Now you're given a formula in your formula book for your exam, which says that the volume is the area of the cross section times by the length. Now it's really, really useful if you remember this formula triangle for that, because if, for example, they give you the volume and the area, you can then work out the length easily without having to rearrange it. So the area of the cross section, that A, represents the shape that looks as though it's been stretched. So on this one on the left, the cylinder, this section here is my cross section. And this is how much it's been stretched, so that's going to be the length. Area of a circle then is pi r squared, and we're going to times that by the length. So pi 4 squared times by 15 gives me 16 times 15 pi, which will be 240 pi. If it wanted it in terms of pi, we could just leave it as that, with the centimetres cubed at the end. But this question wants it to 3 significant figures, so that's going to be 754 centimetres cubed. Now same again for this triangular prism. We're going to do the area of the cross section times by the length. This time the cross section is this triangle, because that's my shape that's been stretched. So I'll do base times height divided by 2, and then times that by this length here. 3 times 4 divided by 2 times by 7 gives me 42 centimetres cubed. Okay, volume of a cone. You're going to be given this in the exam, and it's really important though that you know that this H here corresponds to the vertical height, the height that's perpendicular to the base. So the way they can make this a little bit harder is by giving you the radius and the slanted height. So before we can even start this, we are going to think about this section of the cone here as being a right angled triangle. And I know that's 5. I want to find this length, the height, and this is 14. So I've got a right angled triangle, I know 2 sides, and one side is missing. So I'm going to use Pythagoras. A, B, C is always the hypotenuse. A squared plus B squared equals C squared. So H squared plus 5 squared equals 14 squared. H squared plus 25 equals 14 squared, which is 196. Take away 25 from both sides to get 171. So H is root 171. So now we know the height. We can just plug everything else in to this formula here. So the volume is 1/3 of pi times by the radius, which was 5 squared, times by root 171. And I'm keeping it exact to keep my answer nice and accurate until the end. So type that into your calculator and we get 342 to 3 significant figures. So for the sphere, the volume is 4/3 pi r cubed. You are given that formula in an exam, so it's just a case of substitution. 4/3 times pi times by 3 cubed, which we are going to have 36 pi centimetres cubed, which will be 113 to 3 significant figures. Just bear in mind they could ask you, say, for a hemisphere in the exam, which would be like half of a sphere. So we'd have to divide our answer by 2, or a quarter sphere. Last question then, density. And this is quite a hard density question because there's 3 liquids involved. There's liquid A, which is mixed with liquid B to make liquid C. We're going to write out our density formula triangle. DMV, and we're going to write down what we know for each of them. So I like to start by just writing down the letters. It's kind of like combined mean or like a two-way table where we can use different bits to work out other bits. So liquid A has a density of 1.2 and it says 150 centimetres cubed of liquid A. And centimetres cubed tell me that it's a volume, so I write 150 by the V. To mix some of liquid B to make liquid C. Liquid C has a mass of 210 and a density of 1.12. And it wants us to find the density of B, so to find this here. Now I can't just do 1.112 take away 1.2. Obviously that's not going to work, it's going to give me a negative. So we just kind of start by filling in the gaps. So the first thing I'm going to do is find the mass of A, and mass is density times volume. So we'll type in 1.2 times by 150, which will be 180. And then we'll find the volume of C. So volume is mass divided by density, 210 divided by 1.12, 187.5. And now we can kind of work backwards. So I know if I look at the volumes to start, 150 centimetres cubed plus something gave me 187. So if I do 187.5, take away 150, that will tell me there was 37.5 centimetres cubed of B. Same for the mass. If we do 210, take away 180, I can see there was just 30 grams of that. And then we will use our density formula. D equals 30 over 37.5, which gives me 0.8. 0.8 grams per centimetres cubed.